Chapter 1, Section 5, estimate the percent of a number. This should be a pretty quick lesson because they say this is a 45-minute lesson, so we should knock this one out in a single day. So, what about vocab terms? Well, you're picking up one for this. It is benchmark percents, which is defined as common percents such as 10%, 20%, and 25%, along with their multiples. Surveys often show results using percents. Depending on how the information is being used, it may not be necessary to calculate exact values. For example, a theater conducted a survey of local moviegoers to determine about how many people to expect for a pre-screening of an upcoming scary movie. You won't see me at a scary movie. They wanted to use the results to decide if they should screen the movie in their large theater or their small theater. The results of the survey indicated that out of 298 respondents, 27% of them planned to attend the pre-screening. How can you estimate to find the approximate number of people who will plan to see the movie? This is the things that we're going to be learning in this lesson. You know how to find percents of numbers such as 27% of 40 by reasoning about the percent as a rate per 100. We've already covered that in the other lessons. And by using bar diagrams, equivalent ratios, double number lines, and ratio tables. The equivalent ratios show that 27% of 40 is going to be 10.8. But do you really need to always be that precise? Not necessarily, and that's where estimating percents of a number come in handy. So they've given us a problem. They've shown us the part 10.8 to the whole of 40 is equal to 27 over 100. How do they get that number? They said, well, what do we have to divide 100 by to get 40? And that was 2.5. It's a whole lot easier to go the other way into that. If you divide 100 by 40, you'd get the 2.5 that you needed. And then you'd say, well, 27 divided by 2.5, that is going to be the 10.8. Let me pause this and we'll do a screenshot so I can show you what I'm saying. So let me try and explain this a little bit better because the textbook kind of shotgunned you on it and said, boom, here's all your information. And my thing's not working. Hold on. All right, now it's working. We knew that we had to go from 100% to 40%. So the way they did that is they took the 100, divided it by 40. Of course, I've taught you that you can take those zeros off the end if you want to, but you don't have to. You can say 40 goes into 1 0 times, 40 goes into 10 0 times, 40 went into 100 2 times. 2 times 40 is 80, and that left 20 left over. Annex in your decimal and your 0. Decimal went up, 0 went down, and 40 went into 200 5 times, which gave you 200 with nothing left over. That is where this 2.5 came from. They just did some kind of voodoo math in their head and all of a sudden, yeah, 100 divided by 2.5 is 40. Therefore, now you take the 27 and you divide that by the same 2.5, and you would say, well, bounce a decimal, annex in zeros is needed, and your decimal goes up. 25 goes into 27 one time. That's going to be 25 with 2 left over. Bring down your 0. 25 goes into 20 0 times. So annex in another 0 and bring it down. 25 goes into 100 8 times, which is going to be 8 times 25 is 200 with nothing left over. And that is where they got that 10.8 from. They made some pretty big leaps there, and I wanted you to be able to see what good quality supporting work would look like for this one. Sometimes it's not necessary to calculate that exact percent. All right? The 10.8 took a lot of work, and do we always have to have that exact number? Some examples of places where you won't need the exact number, maybe be estimating the tip you're going to leave for a restaurant bill, how much money you're going to save when you go shopping on a % discount, or how many people they can expect to see in that scary movie. None of those require an exact answer. If you can get in the ballpark, you're going to be pretty good. So, when estimating a percent of a number, you can use benchmark percents. And there's that definition. If you did not write it down, you do need to write that one down. A benchmark percent is a common percent such as 10%, 20%, 25%, and their multiples. You can often perform mental calculations and corresponding fractional values. Now this would be a good time for me to stop and say something. They're saying mental. Even though they're saying mental and use mental math, you still have to give me quality supporting work to justify your answers. You can't just throw down numbers without any supporting work to go, and I'm going to show you what that supporting work looks like. Suppose you wanted to estimate 27% of 40. You could use a benchmark percent of 25%, okay? Because 25% is pretty dang close to 27%, right? So instead of, you can see down here, instead of doing 27% of 40, they decided to do 25% of 40. And let me take and grab a screenshot of that, and we'll look at it closely. Now, if you look at your bar diagram here, you see that 25% as a fraction is 1/4. That's important. And fractions, I will tell you all year long, fractions are your friends. They make doing math so much easier. So let's jump over to where we have our problem written, and we estimated 27% of 40 to be 25% of 40. Well, we know that 25% as a fraction is 1/4. Of is a fancy mathematical word for multiply, and 40. And this goes right back to what we did in our review lesson 1 at the start of the year, multiplying fractions. We're going to simplify before we multiply. 4 goes into 4 1, 4 goes into 40 10 times. That's going to equal 10 over 1, also known as 10. So you could estimate that 27% of 40 is going to be, I need a squiggly equal sign here, about 10. And that's exactly what they did here. They said 1/4 of 40 is about 10. This is showing your work. This, you're missing a few things where they put the 40 over the 1. They didn't simplify the fraction before they multiplied, but they did end up coming up with the same answer. Now, why do you think the estimated value of 10 ended up being less than the 10.8 that we got when we actually calculated it? Well, maybe because the 25% that we used was less than the 27% that they gave us. That's the reason our estimate was a little lower than what the calculation gave us. Now we're going to take a look at several different benchmark or examples of benchmark percents using fractions. So if we have them as fractions, you can see that you've got 0/4, 1/4, 2/4, 3/4, and 1/2, also known as 4/4. And for fifths, they got in the middle bar, and then for tenths, they have in the bottom bar. If we threw in our percents with that, it's going to look like this. So say, for example, if you wanted to know what 60% is, well, 60% is 2/3. Fractions are our friends. I'm not 2/3, 3/5. And so we're going to use 3/5 in order to calculate our values. If you wanted to know what 70% is, that's 7 over 10. So we would use 7/10 to calculate our values. You need to pause and write this into your notes. This is some important stuff here. You can also use rounding to estimate the percent of a number. When estimating 27% of 40, you might instead change that 27%, it's rounded up to 30. Now this isn't my preferred method, but it does work. So to do that, they've got the proportion set up where you have your percents on the right, 30% compared to 100%, and we know that 100% is going to be 40, and we want to find out what 30% of 40 is going to be. And we need to ask ourselves, what do we have to do to 100 to get to 40? Well, we discovered in an earlier problem that 100 divided by 40 equal to 2.5. So that means that I need to take 30 and divide it by 2.5 as well. And taking that 30 divided by 2.5 is going to look like this. First number, it can be bounce a decimal outside of the wall, decimal inside, same number of places to the right, annex zeros and move your decimal up. 25 goes into 30 once, which is 25 with 5 left over. 25 goes into 50 twice, which is going to be 2 times 25 is 50 with nothing left over. So our missing value for x is going to equal to 12. Once again, that's not the same answer we got the other way, but it is a solid representation. This is a good example of showing your work for it. What the textbook is throwing down for showing your work, it's not as good as mine. Now, sometimes you might also find it beneficial to round both the whole number and the percent. So, say for example, if you wanted to estimate 27% of 22, well, they took that 22 and they rounded it down to 20, and they took the 27 and they rounded it down to 25. So now they're looking for 25% of 20. And there's several different ways you can do it. If you were to use the equivalent ratio method, that would mean we'd have 20% compared to 100%, where now 100%, I'm sorry, not 20% to 100%, it would be 25% to 100%, and 25% of what? 20. And these numbers are what we call compatible numbers, because 20 goes into 100 how many times? 20 times what equals 100? Well, that's going to be 5. That's super easy to do in our math. So now we're going to say what number times 5 is going to equal to the 25 that we have right there. Once again, that's going to be 5. So the number for our x value for this one is going to be 5. And you can see we're going back to the textbook page. Come on, let's get back there. That's exactly what they came up with. They said that 27% of 22 is going to be about 5. Now you can also use other benchmarks percent, such as 10% to find, say, 30% of 40. How could you do that? We're going to look at stuff like that. Marita and her 5 friends went out to dinner. Their total bill was $47.45, and they would like to tip 18% of the bill. How much of the bill should they leave as a tip? Well, first off, when you think about it, is 18% of $45 or $47.45 can be less than, greater than, or equal to $5? Well, I'm going to do a little ballpark in my head. I'm going to change that 18% to 20, and I'm going to change the 47% to 50. And I'm going to say, well, 20% is 1/5. Let me show you what I'm doing in my head. So, like I said, I took that 18% and I said that's about 20. And I took that 47.25 and I said, well, that's about 50. And so from there, I said, well, what is, whoops, put in the wrong number, 20% of 50? Well, that 20% is 1/5, right? Look, if you go back to the table, 1/5 of 50 over 1, simplify and multiply, that would give you 10 over 1, otherwise known as 10. So you'd be looking, 20% of 50 would be about $10. So going back to the question they asked, is it going to be greater than, equal to, or $5 or less than $5? It's going to be greater than it, because it's going to be ballpark close to $10 that they're going to leave as a tip. Now, if you wanted to look at that same thing using a bar diagram, you can see where they took and broke it down. They had the 18%, they changed to 20%, just like I said. The 47.45, they changed to 50, just like I said. And from there, they put all this in a bar diagram where all of it added up to be $50, and they broke it down by percents, where you had 20, 40, 60, 80, and 100%. So 20% of $50 is going to be about $10. Now, bar diagram's a perfectly good method. It's not the one I would have used. Using equivalent ratios, another way you could do it. Once again, they've got it set up the same way, where you said 100 divided by what's going to be 50, that's 2. You can see they did that over here on the right. And then since they divided 100 by 2, they also had to divide 20 by 2. 20 by 2 is equal to 10, so 10 went in there. So either method you use, 18% of $47.45 is going to be about $10, and therefore Marita and her friend should leave a $10 tip. We're going to check our answer, and both of those did check correctly. Let's keep moving. Now, a classmate rounded $47.45 to $48, and then they said, well, 20% of $48, that's going to be $9.60. Is this a valid strategy? Yes and no. I mean, did they round here? Some. Could they have done something easier? Yeah. Who would be closer to the correct answer, though? The classmate or us? Actually, the classmate would be closer to the correct answer, to the true number. But the methods that we've learned are actually easier to do it with. Now, this is where we're going to stop part 1 of estimate a percent of a number. Come back and watch part 2 as well. Take some good notes so you understand how to do your assignment.